Hello, welcome to the next session in this series. In the previous session, we ended on question number 33. Okay, so in this session, we'll start with question number 34. Okay, so the question says the set H equals the set A, B, C, and then M is C, D, E, F. C, D, E, F. A subset of the universal sets right here, A, B, C, D, E, F. Okay, so we need to use this information to answer questions number 34 and then 35. So question number 34 says find H complement intersection M. So first we need to find what H complement, and then we find the intersection between that and then M. Okay, so let's find H complement. Okay, so we have H complement will be all the elements that are in the universal set that are not in H. Okay, so here we have A, so that cannot work. We have B here, we have B here, so that is not part. We have C here, we have C here, that is not part. So now the rest is what? D, E, F. So that will be our H complement. Okay, so let's write that down. We have D, E, F. Okay, so that's H complement. And now we have also M. M has been given to us as C, D, E, F. Okay, so let's write it down. M is equal to the set C, D, E, F. Okay, so now the intersection of this and this is what? The elements that are common in between the two sets. Okay, so now let's look which elements are common. We have D here. Do we have D here? Yes, we have D there. Okay, so that D goes into the set. Okay, so let's write H complement intersection M is what? Set. Let's start. We have D here, we have D here. Okay, so D goes. We have E here, we have E here. So E goes. Okay, E goes. Okay, and then we have F here and F here. So F goes, right? So F goes. That's it. That is the end of our set. Okay, so D, E, F is our answer. D, E, F. Do you have D, E, F in the option? Says we have D, E, F, which is C. So our answer is what? C. Okay, cool. Now go to question number 35. Question number 35 says find, into brackets, H intersection M complement. Okay, so we need to first find H intersection M, then find the complement of that. Okay, so let's find H intersection M. H intersection M means the elements that are in H and also in M. Which elements are those? We have A here. Okay, we have A in H. We don't have A in C in M, so that cannot be. B here, B not in M. Okay, C here and C here. Okay, so our common element is what? C. Our common element is C. So let's write that down. We have H intersection M is what? The set C. That is the only element in the set. Okay, so now the question says we should find the complement of this. We find the complement of the set. The complement means the sets that are in the universal set but then are not in this set. Okay, so we only have C over here. That means everything apart from C will be included in our complement. Okay, so let's write that down. So we have H intersection M complement will go to everything apart from C. Okay, so that will be A, B, D, E, F. So that is our answer. This is our answer. Okay, so do you have it in the options? A, B, D, E, F. A, B, D, E, F. That's right here, C. So let's circle that. C is our answer. Cool. All right, let's go to the next set of questions. Okay, here we have question number 36. It says, given that P is equal to the set S such that 1 is less than X less than 6, and Q is equal to the set such that S is 2 less than or equal to X less than or equal to 10, where X is an integer. Find the number of elements in P intersection Q. So this expression right here means find the number of elements in this set P intersection Q. So first we need to find what's P intersection Q, then we find the number of elements in that set. That will be our answer. So now let's write down P and let's write down Q, then find the intersection. Okay, so what's P? P is equal to the set between 1 and 6 non-inclusive. Non-inclusive because we don't have an equal to sign here. Okay, so from 1 to 6 non-inclusive, what do we have? 2, 3, 4, 5. Okay, so that's from 1 to 6 non-inclusive. And then Q says from 2 to 10 inclusive. It's inclusive because we have the equal to signs here, less or equal to. So 2 and 10 will be what? Inclusive. Okay, so Q is the set from 2 to 10. Okay, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the set. So now we need to find what? P intersection Q, because we want to find the number of elements in P intersection Q. So that means the elements that are common to P and then Q. Okay, so we have 2 here, we have 2 here. Okay, we have 3 here, we have 3 here. Okay, we have 4 here, we have 4 here. Okay, we have 5 here, we have 5 here. Okay, so those are the elements that are common. So that will be our set. Okay, so P intersection Q means all the elements that are in P and Q together. Okay, that are common to P and Q. That is 2, 3, 4, 5. Okay, so now this is our P intersection Q. But the question says the number of elements in this set. Okay, so how many elements do we have? We have 1, 2, 3, 4. Okay, let's count it. 1, 2, 3, 4. So these are 4 elements. 1, 2, 3, 4. So answer, number of P intersection Q equals 4. That is our answer. So answer is what? 4. So let's circle 4. Cool. Let's go to question number 37. Question number 37 says, given that T is equal to the set X is such that -2 less than X less than or equal to 10, where X is an integer, what is the number of elements in T? So this expression just means what is the number of elements in T. So first we need to write down the element in what? T. Let's write down the element in T, then we count the number of elements. That will be our answer. Okay, so first let me draw a line here to separate it. Okay, so this is question number 37. Okay, so now let's write down T. T is what? The set between -2 and 10. But here we have -2 to be non-inclusive because it is just less than. Okay, and then we have 10 to be what? Inclusive because you have less than or equal to. So 10 is what? Inclusive. So from -2 to 10, and then 10 is inclusive, but -2 is non-inclusive. So we start from what? -1. We start from -1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is our set. This is our T. So now to find the number of elements, we just need to count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our answer is 12. Our answer, N of T is equal to what? 12. end of t is equal to 12. Cool. So that is our answer. That is our answer. 12. 12 is our answer. Okay, we circle that. Let's go to question number 38. Question number 38 says, in the diagram above, x and y are finite sets. Which of the following statement is true? So we just need to look at the options here and see which of them is true. So let's check that one by one and then we see. Okay, here it says x complement intersection y is equal to y. So x complement here means everything outside of x, right? Everything outside of x is equal to y. Okay, that is possibly true because y is not in x, right? Y is outside of x. So it is possibly true that the intersection between x complement, that is everything outside of x, and y might be y, because that is the only set we have here. Okay, y is the only set we have outside of x. So this is possibly true. Okay, let's underline down for now. Let's underline that for now. Okay, now let's go to the next one. So it says b says x complement intersection y is equal to u. This is absolutely false because the u here means everything in the box, but we are saying x complement will not include x. Okay, so this is absolutely false. This is absolutely false. Okay, now let's go to c. So c here says x complement intersection y is equal to x. This is also false because how can you have the intersection between x complement and something to have x in it itself? This is actually not impossible. So this is actually impossible. Okay, so this is also wrong. Now let's go to d. This is y intersection x equals x. No way, because y intersection x means elements that are common to y and x. But here we see that these sets are what? Not joined together, so there's no way they have an intersection. X and y will not have an intersection because what? They are not together, they are disjoint. Okay, so this is the answer. Our answer is A. Our answer is A. Okay, thank you so much for watching this session. In the next session, we'll move on to question number 39. So let's end here because our time is on. Okay, thank you very much for watching. See you again next time. Bye.